Let's have a look at Matplotlib and this piece of code to understand what it does. So in machine learning, it is very important to have the ability to draw graphs and quickly analyze the information. So what we'll do here is we will look at how do you actually generate a plot, how do you specify its axes and the labels on them, and then how do you actually display that graph. So here, the first line that we need to look at is this one, which is the import statement. So what we are doing here is importing in the library Matplotlib, and within there we are using the module pyplot. So if we run this code and see what we get, and so we can explain what's actually happening. So if I click on execute code, and here you can see how long it took to execute this code. It's been very quick. And over here, if I scroll down, so as you can see here, we have a simple graph, a line graph. This is how it looks like automatically. On here, few notable things are the y-axis, the x-axis over here, and you can see the labels for the axis. Now, the labels for the axis were done automatically. So if we go up here in our code, you can see that all we specified are the values. And if we have a look at the first value, so we go 1 here, that's the x-axis, and at y-axis, it is 4. If we go down to our graph, so you can see the first value here, which is up here, and goes up to there, and then it connects to 4. And if we have a look at our next value, next one is 2, and it connects to 5. So we can see 5 is over here. Over here is, we can draw that line all the way from 5 up to here. The 5 is here, so that would go all the way down. And then if we go down from there, that point, that takes us to 2. And these are the values that we had. So we had 2 and 5 shown here, which were plotted. So then you can see the labels here. So the label that we have actually appear here. So you can see that the label there, y-axis, and there's a label here, x-axis. And this is what we called our x-axis and y-axis. The show method is actually what displays the graph. And you may be wondering, how did we get a line graph? By simply using this command, plot over here. That's what generated a line graph. Now, there are a few issues with this graph. As you can see here, what we have is the tick marks for the y-axis are not to our liking. So they have decimal places over here, which ideally we do not want. And you can see here that there are decimal places even for the x-axis. This has been done automatically by the pyplot over here, and within the plot function over here. So the plot function over here has created those tick marks for us. And these tick marks have been generated automatically. So we didn't create them. So it knew the maximum value and it knew the minimum value to go for over here and over here. So previously, using this code, we generated the graph over here. So here you can see we've got the x-axis and the y-axis, and you can see a line has been drawn over here. And this line has come as a result of the x values here and the y values here. So this is a very simple function. So this function over here belongs to the PLT, and this PLT is over here, and that comes from the pyplot module, which is part of the Matplotlib library in Python. And you can see here we defined the X labels and the Y labels. So what I want to show you is this is actually a module. So a module can have variables stored in it. This library here, you can see that we are not creating a class of this. So what we are doing is we are just using the function, and that function behind the scenes stores these values in a variable. So it creates the drawing surface that we see here, and those values are then shown in the graph. So by just calling the show function, it will display the graph. There's a couple of things that I want you to just understand here with the graph. When you hover over, you've got option to copy this. So by using the copy button over here, you can copy the graph. You can expand the image. So this will open it up in its own tab over here, and you can save the image. So if I click on the save image, you can see here, you can save it as a PNG file over here, and then save the plot image, and you can save it in any folder that you want. You can name your image over here, and if you want to cancel, you can click the cancel button. So as you can see, our graph has been generated, and these are some of the things that we can do with this graph. One thing that you may have noticed is when you click on this graph button over here, there are 3 versions of the graph, one over here, and one over here. This is because every time you click on this button over here, it adds a new graph. For example, what I've done is I've added some new values here. So I've added 20 and 12 there. And the reason for these new graphs is so it can store history. So you can see the new graph now has this values. If I go back to our graphs, you can see here that we now have a graph with a value of 20, whereas if I go to one of the previous ones, you can see that it had a value of 6. So the reason is so you can track the history of your graphs in a single place. So that's why it adds a new entry every time there is a graph over here. And you click this graph button. So it saves the history automatically for you. And then you can save these graphs here to different formats. And for example, you can save them as PDF, PNG, SVG. So if I were to save them as PDF, and one thing that you may notice is this save as button only gives you the option to save it as a PNG file. But if you go in here, you can actually get a secondary save button over here. And this save button actually behaves differently. So you can click save and it lets you save it as a PDF, PNG, or SVG. SVG is not actual SVG file. It will actually have just the PNG data in it. So it's not an actual SVG file that it saves. But PNG and PDF are available here. Whereas previously, by clicking this save button over here, you only get the PNG format. So as you can see here with this code, one thing that we are not doing is specifying the tick marks on our axes. So we are specifying the axis label here, y-axis, y and x-axis over here, and then we are specifying the values that go in. So for example, we have the values here. These are the x values and these are the y values. But what we are not doing is specifying what these tick marks should be. With this, these are automatically decided. So if I add in another number here, for example, 9, then if I add in 20 here, and if I run this, you can see that the tick marks have changed. So they have changed on this direction. They no longer have decimal places. So what we can do is we have, if I remove these over here, you can see the values will change the tick mark. So if I run this, you can see that the Matplotlib library itself decides what labels should go in. So if I scroll down over here, and you can see for this, it has the decimal points, and these decimal points are annoying. So how do we define these tick marks ourselves? So what we can do is we can actually specify the tick marks by using the xticks option here. So plot.xticks and plot.yticks. And you can see the values we can specify over here, 1, 2, 3. So that's what we want the x values to be, because these match up with the values we have here. So these match up there. And of course, we can specify the same for y here, and the tick marks we want 4, 5, 6. So this is quite easy to do. And then again, we got the y label and the x label. So if I run this, and you can see now the output has changed. We've got values 4, 5, 6 for this one, because that's what we specified. So if you look over here, we had 4, 5, 6, and that's what's been specified. So if we go down here, and for the x-axis, you can see we got the values 1, 2, again, because we specified 1, 2, 3 there. So you can use the xticks method over here and yticks method, and these allow you to have the right ticks for your graph. But if you don't specify anything, so for example, here we didn't specify anything, all we did was we imported the library, we set the values for the x and y, and we just set the labels and we showed the plot. So if we don't specify the tick marks, then we will get given the random ones that Matplotlib thinks are the best ones. So what you can do is you can use these over here, and that will let you be very specific with your tick mark. So just remember the xticks and ytick methods over here that belong to the pyplot module that we are using. One problem with these tick marks over here is we have to specify them manually. So we are specifying, for example, for the x that it can only have these values, and for the y it can only have these values. But what if our x values here change and the y values change here for the plot? So if we look over here at our graph, and what you can see is we can see the value of 6 over here. And if we go down here, you can see the maximum value is 3. So 6 over there, 3 over here. And you can see the minimum is 1 and 4 for the y. The reason is because we specified 4 here and we specified 1 here for the x1. So what if our data changes? So what if we only have values that at the minute it's fine. It goes up to 1, 2, 3 and 4, 5, 6 for the y value. And you can see here the 6 over here is actually reflected here, 6 over there. So that is fine. But what if we add another value here and we say it goes up to 20? So the y values go up to 20 and we can say that the x values go up to 9 over here. What do you think will happen to our graph over here if we specified our tick marks here manually? What will happen here and what will happen over here? So if I run this over here, you can see what has happened is the values here have been collapsed or squished over here, and the same thing has happened here, and suddenly we have this whole section which is empty and the whole section here which is empty. So that's to be mindful of, that if you specify x ticks and y ticks manually, then you will get a graph that looks very strange. So it looks like this, and you can see the both axes not behaving correctly. So you must be careful when using x ticks and y ticks here and manually setting them, because you may get an undesired outcome. So previously we looked at x ticks over here, and we saw that if your values change over here in the data, then your x tick suddenly becomes a bit of a problem because you had to manually specify the values for the x tick. So as we saw in this graph, what we ended up with was the values got squished over here because they only go up to a maximum of 3, but our data point actually went up to 20 over here and 9 for the x-axis. So the y-axis went up to 20, and as we saw over here, there 20, there is no value because we specified 3 and 6 as the maximum. So a way to resolve this problem is by using GCA function over here. GCA functions basically allow you to access the axes for x and y. What we are doing is we are accessing the y-axis and the x-axis. So this function makes this available to us. So it accesses this variable in the background. And then what we can do is we can call a function on here. So this is called set major locator, and set major locator for both the y-axis and the x. And then within here, it takes in a parameter. So the parameter that it takes in is coming from the plot library class that we have. So over here, we had the plot class. And if we go down back over here, so it has a class called maxNLLocator. So this class actually takes in this argument over here where integer is false. So what we are doing is if we set that as false, then we will get decimals. But if we set that as true, and if I set that as true over here and true over here, run this over here, you can see that we had values going up to 20 and 9 over here. And if we look at our graph over here, and you can see this time around, the values go up to 20 and the values go up to 9 over here. And our graph works as expected. Notice that we did specify that there be no integers, and those are shown correctly. If we reduce this and see the effect of the integer values, so if we change this to false, so here I've changed both of these values to false, and if I change the values here, so if I reduce this back to our original numbers that we had, and if I run this, and you can see by default we get decimal places in our labels here for both axes. So what we can do is if we set one of them as true, so we will set the y-axis over here and we'll set the value for this one to true. So we shouldn't get any decimal places over here. So now I've set this to true. Let's see what happens over here with the value of 6 and 5.75. So I will just click the execute button over there, and you can see that what has happened over here is we have the value of 6 over here and 5 over here, and it has nothing in here as decimals, whereas previously this had decimals. This is because we set this to true or integers, but I want you to notice for the x-axis, it's still set as false. If we scroll down over here, and you can see that the x-axis still has decimals shown because set this as false for integers. So I just want you to be aware that when you are working setting the tick mark, you can use the GCA to get the access to the axis, and then you can use this function here, set major locator, has this class over here, and it has a parameter for integers. So rather than manually, so if we go up here, rather than manually specifying the tick box over here, and then when your data changes, you end up with a problem like this, where your values are over here 6 and 3, but your data has now expanded even further and you don't end up with any tick marks on your graph. So rather than use this over here, you should use this over here using the GCA x-axis, access the axis, and then set major, and then pass it the following parameter, and it will do the rest for you. So as we see in here, that if we use the GCA function over here and we set the y-axis and x-axis tick mark using an automated sort of method within the Matplotlib library, then we get an output that is sort of not in our control. So here it determines the maximum values here, 6, because if we look at our data, then we have the value of 6 for the y-axis. But if we change that to 20, for example, and run this again, you can see that it will automatically change that to 20 because we have specified 20 over there. So what we need is there a way to modify this behavior even further? So for example, if we have the values here, 18, 16, 14, we don't know what the value is that determines the gap between these tick marks. So what we can do is if we scroll down over here, we can use the following. So again, notice here that we are still using GCA and we are still accessing the y-axis or the x-axis, and then we're using set major locator. So if we scroll up, you can see when we had the set major locator, y-axis, GCA, this is pretty much the same. The only thing that changes is this time we are going to be using plot multiple locator, and previously we used plot max mn locator. So rather than use this, what we can use is we can use this over here, and notice that it takes in an argument. So it takes in an argument over here, and you can see I have put argument for the y-axis as 4 and for the x-axis as 2. So what this will do is it will jump the tick marks by 4 every time for the y-axis, and it will jump 2 tick mark for the x-axis. Whereas if we look at our code here before, we were only able to determine the gap between these tick marks. So remember that we also had the integer here as false. So when we scroll down here to the x-axis, you can see we have the decimals. With our new method over here, you can see we're using a slightly different class over here. It's called the multiple locator. And if I were to run this over here and see the output, and now you can see something. The gap we selected was 4, and the gap that we have here, 20, 16, 12, is by 4. And if we go down here, the gap for the x-axis over here is 4, 6, so it's separated by 2s, and this is because what we did over here was we specified 2. So this is how you can control your axis gaps over here by using the plot multiple locator and then specifying what you want the bucket sizes or the gaps between your tick mark. And all you need to remember is still using the GCA and the x-axis and the set major locator. But if we look at the previous one, you can see it's pretty much the same route of accessing it, but here in the argument, we just give it a different class. We still access the plot, but we gave max n locator and then a parameter over here. But for the other one, we just access from the plot, we access the multiple locator and then pass it how many bucket sizes we want. So in this instance, we said to separate each bucket size by 4. Another useful thing you can do with the axes and the tick marks, we're using the GCA and then we're accessing the y-axis and set major locator. So remember, this function is very useful and you just need to remember it. What this allows you to do is set the maximum number of tick marks automatically. But what you can do is you can specify things such as whether you want to use integers or not. So here, for example, for the x-axis over there, we said we don't want to use integers, so it will allow for decimals. So this is false. Integers, if we change that true, it will only use integers. So if we go down over here, and you can see for the x-axis, we have integers over here that are set to false. So that means it is using decimals. Whereas for the other one, it's not. Now notice here, we didn't specify this parameter is actually optional. So over here, this is optional for you. But what you can do is if you set minimum number of tick marks, let's say if you set that to 25, and if I were to run this over here, notice here that because it needs 25 tick marks, it has automatically added decimals in here. So what we can do is we can take this integer false and we can add that over here and change this to true. And if we now change this to true over here and we set 25 tick mark, let's see what the effect is on the tick marks here for the y-axis. The reason it's y-axis is because we selected y-axis here. So if I were to run this over here by clicking the play button, you can see that the effect of integer equals true over here has had no effect over here. But if we change that to 20 over here now, let's see what happens now. And you can see that it's still adding in the decimals over here, which is not what we want. So if we reduce this to, for example, 10 tick mark, you can see that it has now changed this into integers only. Notice that there is no decimal place here. So if we now change this to false over here and run this again, notice here that the behavior of integer over here with false, even though we have less tick marks, is still very unreliable over here. So what we can do is change this to a smaller number, for example 2, and if we were to run this, you can see here that the behavior again is unpredictable. But if we remove this parameter over here and run this again, and you can see the integer parameter or argument here has no effect on the actual y-axis. So this is a bit of a strange behavior that you need to be aware of. But I want you to notice where it does have an effect. So integer equals false over here. And what you need to do is, if you were to scroll down here and look at your x-axis, you can see here we do have decimals, the numbers. So if we go up here and change this to true, and if we were to run this again, what you will see is now that we have changed this to true, and if we come down to our axes, you can see they are as expected. We didn't want any decimal in them. So one thing to be sure about is when you do use this integer equals true, it will always give you integer. But if you mix it up with other arguments and parameters like we did, then you may end up with unexpected results. So here, what we'd like to do is change the color of the label here for the y-axis, and the label, actually, we just call the y-axis. This is something that we have set over here. So you can see that we coordinate the y-axis and x-axis over here as the label. So what we can do is we want to change the color of y-axis over here, and also we want to change the color of these tick marks. So what we can do is we can use the function GCA, which we are familiar with previously. So we used it to basically set the major tick marks, and we said we wanted those tick marks to be separated by 2. So the gap between each tick mark should be 2. So what we can do is, that's why we had a situation. So each one is separated by 2. We can do the same thing over here. So using GCA, so notice here we GCA, we can actually access another function called tick params, and this tick param actually takes in an axis we want to change. So we want to change y-axis, and we want to change the color to red. And for the label, what we want to do is, notice here, if you don't have to specify that, this is an optional parameter. So for the y label, we want to change the color to blue. So we specify the color argument here and pass it the value of blue. And if we were to run this, you can see the output that we get on the graph is we get these in red over here, and we can see that the label has changed to blue color. But notice this has only happened for the y-axis and not for the x-axis. So these are still in black. So what we can do is, rather than specifying, we can change this to blue as well if we want. So we can copy that over here and paste it there, and notice now if I were to run this, that both our labels have changed to blue, same as the y-axis over there. But notice that tick marks have not changed the color. So what you can do is you can come over here and where it says axis, and if you change that to both, so we have now changed this to both. And if we were to run this over here, and what you can see is this has now changed to red over here as well. And if you wanted just the X one, then you can specify in this axis as X. So if I go in here and type in X, and now that we specified X, the effect of this will be is that this will change into black, while this one will remain as red. So if we were to run this again, you can see that we specified X to change into red, but we didn't touch the Y-axis. So by using here the X-axis over here, this parameter, you can change the color. Let's have a look at our graph over here. You can see that it is pretty plain. there isn't much color onto this graph. So here, this is in black, this is in black. We got the axis here in black and the label for it in black. So ideally what we want to do is we want to add some colors, and also how do we add tick marks over here, so to make it a bit more interesting. This was quite a common task that you will probably need to do in machine learning. What you can do is, here are the different elements you can do. So first of all, for the axes, what you can do is you can specify for the x-axis, this is for the tick mark, so this is the tick params function that we're using, and GCA. So for the x-axis, you can say we want them to be in red, but the y-axis, you want them to be in blue. So what you can do is, if you were to run this, then your axis would change color according to the setting over here. Now notice again the use of GCA. GCA is very popular. So as you can see here, we use GCA to access the axes and set the major tick mark. So if we scroll down here, what we are doing is we are setting the tick mark, accessing the tick mark parameter, and we are setting the color here. And what you can do is you can also change the add-in using GCA again for x-axis. Notice here the x-axis that we access. So here we access to set the media locator. If we scroll down here now, what we are doing is set the minor locator over here. So this function again takes in a parameter, and we can see the arguments are pretty much the same, multiple locator. So if we go up here, you can see we use multiple locator here, and we said we want a gap of 2, which is what happened over here. So you can see it left a gap of 2 between the major tick mark. So if we go down here now, and as you can see, we set gap of 0.5 for the x-axis, and for the y-axis, we want a gap of 1. So this will give us a mark in between here. So there should be a mark in here, a mark in here, 6, 7, 8, and 9 over here. So if we scroll down here, you can also change the color of the tick marks. Notice here that I am using both. If you use both, what that means is it will change it for the minor and the major. So what we mean by that is it will change the color of this tick mark over here and the value, and it will also change it for the minor one that goes in between these. So if we were to run this over here, so you can see you can actually specify that you want the minor to be in a different color, such as pink for a specific axis. So if I were to run this code over here, you can see various things have gone on, which is it has changed the tick marks here to red for both for the x-axis, but for the y-axis, you can see the major tick marks are in blue, but the minor ones are in pink. Now it's very hard to see here, so I will just zoom in over here and show you that they are in fact in pink color over here versus blue over here. While for the x-axis, you can see that the major ones and the minor ones are in red color over here. And notice there are more tick marks here. This is because in our code, if you have a look at this bit over here, we said every 0.5 we want to tick mark, and that's exactly what has happened. While here the tick mark is after every 1 unit. So if we go down here, so we have a tick mark at position 16, which is a major, and then 17, 18, 19, and 20. And then you can see the axis label again. We can change that to blue. It has done over here, and you can see that we have changed this to blue over here. So just by using the GCA function, you can modify a lot of things on your graph, and you can do them individually, different colors and so on. And remember, you can use pretty much same method as setting the major ticks, and you can do the same for minor ticks over here. It's very similar syntax. And then using tick mark parameters here, you can actually change the colors for both major and minor, or you can be very specific and say you only want minor.